All right, today we're going to do special functions. The first one we're going to do is called a step function. It's a graph of a series of line segments. So short line segments, they look like steps. Because each part is linear, this type of function is what we call a piecewise linear function. Because it's pieces of a linear function. All right, one example of a step function is what we call the greatest integer function. And it's written as f of x is equal to, what we call that greatest integer of x. Okay, that's what the two brackets are around x. Okay, what it's asking for is the greatest integer not greater than x. So an example, okay, of the greatest integer function of 6.8. What is the greatest integer not greater than 6.8? It would be 6. Okay? No. All right, so let's do the greatest integer, okay, function of negative 2.5. So what would be an integer that is not bigger than negative 2.5? Okay? The answer is negative 3. Okay, because is negative 2 bigger than negative 2.5? Yes, it is. So could it be negative 2? No, it'd have to be negative 3. Okay, that's all greatest integer function is. What's the closest integer without going past that number? All right? This is what a greatest integer function looks like. This is the parent function. You don't have to write this down. Just look at it for a minute. This is what it looks like. This is the parent function. This is the base, where it's just f of x is equal to the greatest integer of x. Does this look like steps? Yeah. Okay. It's a linear function because we have lines, but it's pieces of those lines. Now each dot, okay, if you remember on number lines, the closed-in dot includes that line. The circle dot does not. Right? So if you plugged in a number, let's just say you plugged in, okay, you've got a table with x and y, you plugged in 1.5, okay, which, let me show you, 1.5 is right there, right? And an x coordinate. What is the greatest function? What is the greatest integer that is closest to 1.5 that doesn't go past 1.5? 1. See how it's right here? It's included. The y is 1. Okay. Now if I put 2, okay, what is the greatest integer closest to 2 without going past it? 2. Okay. So once it gets to 2, see how that's an open circle? Okay. Because where does it begin? It begins right there. Okay. That's why it's a closed circle at 2. Okay. Anything up to 3 is going to be a y of 2, right? But once it gets to 3, what's the y coordinate? 3. Right? So x of 3.3 is at 3. 3.4 is 3. 3.999, what's my y coordinate? 3. But then when my x is 4, what's my y got to be? 4. So does everybody understand piecewise? Okay. The domain, okay, what we say the domain is. Domain is all of the x coordinates. Okay, domain is all x coordinates. What would be the domain of this? What x coordinates are included?
Negative 4, negative 3, negative 2.
Okay, well this would continue on. I just didn't finish it. And it continues on here. Is there any x coordinate that's not included? No, so my domain is all, okay, all real numbers. So in your notes, write f of x of greatest integer of x. Okay, domain is all real numbers. My range. What will be my range? Remember, range is y coordinates, right? What y coordinates are included in this graph?
Wait.
Okay. What y coordinates? Okay. Does it? Okay. Remember, it continues on. Okay, and it goes up.
All the way through.
Okay, all of the y coordinates are included if they're an integer. Look at this, -3, -2, -1. Does it include 1.1? -1.1? -1.2? -2.9. Is that included? No. What about 1? Is that included? What about 1.1? 1.2? No. So what could I say is my integers? It's all integers. Or what can I say about my range? It's all integers. Okay? It is any number that's an integer. That's included. But if it's not an integer, like 1.1, is that included? No. So my y coordinate, my range, is just integers. Alright, so here we have graph f of x is the greatest integer function of x plus 2. We're supposed to state the domain and range. That'll be on your homework. Make sure you do that. Alright, I've already went ahead and made a table of x, okay, of x plus 2, and then the greatest integer of x plus 2, which is the same thing as my y coordinate, right? Okay. So if I plug 0 in for x, what is 0 plus 2? 2. What is the greatest integer not greater than 2? 2. I have 0.5 for x. What is 0.5 plus 2? 2.5. What is the greatest integer, okay, closest to 2.5, not going past it? It is 2. Let's do 1. What is 1 plus 2? So what is the greatest integer closest to 3 without going past it? 3. What about 1.25? Okay, 3.25. What's the greatest integer not greater than 3.25? 3. What about 2? 4. Greatest integer close to 4? About 2.75. 4.75. What is the greatest integer not going past 4.75? 4. Okay? So now what I can do is I can graph it. At 0 for my x, okay, it includes 2, right? 2 on the y. I got bigger on the x coordinate. I got closer to 1. What is still included? What's my y coordinate? It's still 2, right? Okay, but once I hit 1, what did it go up to? 3. So I don't include 1 at 2 on my y. I include it at 3. And then it goes all the way up to 2, but does it include 2? No. Right? 4 does. So I don't need my graph of my table to do all these numbers. I can just continue on graphing it because now we know what it looks like. It looks like the parent function, except it's 2 higher. Okay? Everything's been moved up to 2. So it's a closed dot, and then it's a line to an open dot. Okay, and I could go backwards. I do a few of them, and I call it good. Any questions on how to graph this? What's my domain? Remember to state the domain. What's my domain? My x coordinates. All real numbers, because is there any x number that's left out? No. 1.2, 1.3, all of it's included, right? So my domain is all real numbers.
What is that 2 though?
Huh?
What is the 2?
And then my range is my y coordinates. What's my y coordinates?
2, 2, 3, 3.
Okay? -1, 2, 3. It's always an integer, right? It's all integers. Okay? It's not every number because is 1.2 included? No. Is there a dot on 1.2? No. Okay? On the y. It's just integers. Alright, so this is absolute value function. This is the parent function. This is what it looks like. Okay, without anything added or changed to it. This is what it looks like. It gives you a V. Okay, now the graph's kind of cut off, but it should look like that. Okay. You remember the absolute value is how far is that number away from 0? Remembering distance cannot be negative. So really all you're doing is you're getting rid of the negative number. All right? What they do is they tell you this. To find it, if x is greater than 0, then your f of x is just x. As in, 1 is greater than 0, so my y-coordinate is 1. 2 is greater than 0, so my y-coordinate is 2. And it goes on like this. If x equals 0, then y equals 0. And then if x is less than -1, or 0, if anything on this side, okay, all you're doing is making it positive. So -1 becomes 1. -2 becomes 2. All right? Your domain is all real numbers. Is there any x coordinate that's left out? No, it continues on, so left and right. So x coordinates are all included. But what about my range? What's my range here? What y coordinates are included and what y coordinates are left out? Look here.
Only the positive.
Okay, only the positive. Okay, the book says all non-negative real numbers. Okay, I'll just take all positive numbers. Because are there any y coordinates that are negative? No. Okay. But it continues on. So everything from 0 on, okay, you could also write it like this. Y is greater than or equal to 0. Because it's anything 0 and up. Any questions on the absolute value function? Alright, write this down. Alright, so we're graphing f of x, absolute value x minus 4. So what I want to do is just to kind of get this started. We know what the parent function looked like. Of absolute value, it looked just like that. So we're going to figure out what minus 4 on the inside does to our graph. So I'm just going to pick a couple points just to kind of, so I know where it starts out. Really what I want to do is I want to find out where the vertex is, where the point where it comes together at. That's what I'm going to try and find. Okay. So what I do is I just pick a couple points, plug them in, figure out what my y-coordinate is, and see if we can figure out what my graph looks like. So what is 0 minus 4? Negative 4, but what's the absolute value of negative 4? 4. So at x is 0, y is 4. When x is 1, what's 1 minus 4? What's the absolute value of negative 3? 3. So when x is 1, y is 3. Negative 1. Let's plug in negative 1.
Negative 5, yeah.
Negative 5. What's the absolute value of negative 5? 5. Have I found the vertices where it comes together yet? No. Remember yesterday the vertices was at 0, 0. Okay? It's not there yet. So keep plugging in some numbers just to kind of see if we can figure it out. What is 4 minus 4?
0.
0. What's the absolute value? 0.
0.
Okay? So I'm thinking this is probably my vertices, but let's do a point on the other side of it to figure out if it goes up or if it's still going down. What is 6 minus 4? 2. What's the absolute value of 2? 6, 2. Okay, so can I go ahead and graph that? Yes, I have enough to graph it. So this is what x minus 4 looks like. Absolute value of x minus 4 looks like. I will just tell you, okay, if it's on the inside absolute value, like this is, the minus 4 was on the inside, it is moving it to the right or left. All right, you'll figure this out later, but this is more for Algebra 2 and stuff. If it's inside, minus 4, it moved it 4 to the right. So what do you think it's going to do if this is x plus 4? It's going to move it 4 to the left. Okay, it's kind of opposite what you'd think. So if it's minus 4, it moves it to the right. If it's plus 4, it moves it here. Now if it's outside, like if this was plus 4 on the outside, you know what it does? It actually moves it up. If it's minus 4 out here, then it moves it down. Okay? You don't necessarily need to know that. I'm just telling you now so when you see it again, it'll make more sense. So you have a parent function of this, and your numbers change it. Okay, if it's on the inside, it moves it to the right or left. If it's on the outside, it moves up or down. If it's being times by something that either opens it or closes it, makes it a narrow V or a wide V. Okay, that's not, like I said, you don't have to know all that, but it'll make more sense later on. Now, what is the domain and what's the range of this, x minus 4? My domain, remember my x coordinates. Are there any x coordinates that's being left off? No, because this continues on to the right and left, so it's all real numbers. Now, what about my range, though? What y coordinates are being included on this graph? All positive. Are there any negative y coordinates that are included? No, because it goes from 0 up, and so it's only positive numbers. It's all positive. Now, like the book writes it as non-negative numbers. Okay, I'm fine if you just wrote all positive numbers. Okay, any questions? All right, this is what you need to write down now. This is a piecewise defined function. This is a piecewise where it's pieces of a graph, and it's defined, piecewise defined, meaning only certain parts of the graph. All right, it depends on what your x coordinate is. If you look here, it said the f of x, you graph negative 2x if x is bigger than 1. But if x is less or equal to 1, then you graph x plus 3. So you're going to have two separate graphs. All right? So let's just pick some numbers here. I'm going to pick 1, and I'm going to pick a number bigger than 1, say 3, and let's pick a number, another number bigger than 1, let's say 4. And let's graph that one, and then we'll graph numbers that are less than 1. Right? X is 1, so which one of these two do I do? Do I do negative 2x, or do I do x plus 3? Look at my x. Okay, is x greater than 1, or is x less than or equal to 1? It's less than or equal to. So I graph this, x plus 1. Right? So what would be my y coordinate if my x is 1? 4. 1 plus 3 is 4. So I go 1, 4, I put a closed circle around it. Because it's included, that's why it's equal to. Now let's do 3. Where does 3 fit? Is it bigger than 3 or is it smaller than 1? Or is 3 bigger than 1 or is it smaller than 1? Bigger. So I graph this, negative 2x. So what is negative 2 times 3? Negative 6. So we go 3, negative 6.
4 is bigger than 1.
Right? And then let's do 4. 4 is bigger than 1, so we do 4 times negative 2, which would be what?
Negative 8.
Negative 8. So 4, negative 8. Now, I'm going to go ahead and I'm going to continue this way, but I'm also going to go to 1, keep going with this slope where it's down 2 over 1, and I'm going to go all the way to where it intersects at 1, because let's plug 1 in for negative 2x, and I'm going to show you why you want to do that. What is 1 times negative 2? Negative 2, right? But instead of putting a closed circle around it, we put an open circle around it. Because it doesn't include negative 2, but includes everything else. Because let's say we went with 1.1, right? It would be close to negative 2, wouldn't it? It'd be negative 2.1. So it's close to 1, negative 2, but it doesn't include it. So that's why it's an open circle. The one at 4 is a closed circle because it includes it. Because if x is equal to 1, then that's the equation you go with. Now, I haven't finished my x plus 3, so I need to do a number smaller than 1. So let's go with 0. If I plug 0 in, what do I get for my y? What's 0 plus 3? 3. So do 0, 3. Let's do one more. Let's plug negative 1. What is negative 1 plus 3?
Negative 2. Wait.
It's 2. So negative 1, 2. Do I have enough that I could draw my line?
Yeah.
Yeah. Am I going, do I finish it to the right or do I finish it to the left? Well, the left. Okay? Because if I picked 2, right, would it be up here or would it be down here? It'd be down here because 2 is bigger than 1, so we graph this. So this is the piecewise function. It's 2 separate graphs or lines, okay, that split off at one point, which in this case it's 1. All right? My domain of this, okay, is all real numbers because it includes all the x-coordinates. It goes all the way to the left and all the way to the right. So all real numbers. What about my range? What would my range be for something like this?
All numbers included?
It's not all real numbers.
No, I said all numbers included.
No. Okay. It includes integers. Hey, but let's think about my y coordinate. Let's look at the y's. How far up does it go?
2, -2.
On my y coordinate, on my y axis, it goes all the way up to 4. Is it anything above 4? No, because look, here it's down and here it's down. So my range we could write is anything less than or equal to 4. Because it does not go above 4. It goes below. Is there anything that says it couldn't be -20 down here? No, because this would get there and so would this. -20 is on both of these. But what about 5? Will 5 ever be graphed on these 2 lines? No. What about 10? No, because they end here. This is the limit. Okay? Really, when you're finding domain range, you're trying to find the limit. Where is the limit to this? Well, the limit on the range is 4. That's the biggest number it can go. Any questions?
This is making.
I put this up here just so you can kind of see what each graph looks like. The parent function. You have a step function, looks like this. The absolute value looks like a V. And the piecewise defined is 2 separate lines. They can be going in opposite directions like this, or like the last problem where they're both going down, but they stopped at a certain point. Okay?
Whoa.
That's what piecewise defined. These are just examples of them. All right? So today, when you're having to graph those and stuff, you know what they're supposed to look like. If it's the greatest integer function, looks like this. Absolute value function looks like this. If it's piecewise defined, where it's several certain steps you have to look for, if x is greater than 1 or 4 or whatever, then it looks like this. Any questions? Here's your assignment.